Going to touch the other graph that we already drew there? No. And this one is y equals 3 times 2 to the x. Everybody with me so far? Now, what do I do to find the y values for y equals negative 3 times 2 to the x? Okay, what else could I do just quickly to do that? Exactly, make everything that's in the second column negative. Negative 3/4, negative 3/2, negative 3, negative 6, negative 12. And let's graph it. Negative 2, negative 3/4. Negative 1, negative 3/2. 0, 3. 1, 6. Sorry, negative 6. And 2, negative 12. Is this going to ever touch the x-axis? No, it is not. What do you notice about let's label it. Y equals 3 times 2, negative 3 times 2 to the x. What do you notice about y equals negative 3 times 2 to the x and y equals 3 times 2 to the x?
They're opposites.
They're what?
Reflection.
It's the reflection. They're opposites. Great. So let's fill in some information down below. The graph of y equals 3 times 2 to the x is a blank blank of the graph of y equals 2 to the x.
You just named them 3 reflections. Stretch.
What kind of stretch?
Exponential stretch.
A vertical stretch. Remember when we dealt with the parent function of y equals x, and we found out stretches happened when the absolute value of a was greater than 1. What is a in this case? 3. What's the absolute value of 3? 3. 3 is greater. That is greater than 1, so it's a vertical stretch. If it was less than 1, it would be a vertical shrink. Okay? So now let's look at the graph of y equals negative 3 times 2 to the x. What is a?
Less than 1.
No, what is a? What's the absolute value of a? 3. Is that greater than 1 or less than 1? It's greater than 1, so it is still a vertical stretch.
Is there a horizontal stretch?
Not this year.
Okay.
But this vertical stretch has a what on the x-axis? You've already said it. It's a reflection. I earn on that money. Sometimes it's compounded yearly, sometimes it's compounded daily. Just depends. But in this case, we have an exponential growth model that we can use. The equation is y equals a times the quantity of 1 plus r to the t. A is the initial amount of money that you would put into the account. R is the interest rate. T is the amount of time in years. You with me? So, let's say in example number 4, I deposited $500 into a savings account that earns 2.5% interest compounded yearly. Find the balance in the account after the given amount of time. So I'm going to use my formula. Y equals A times the quantity of 1 plus R to the T. What is A in this case?
500.
500. 1 is always constant, never changes. What is R in this case? 2.5 what?
Percent.
So what do I need to write here? 0.025, because we always change our percent to a decimal. Raised to the power of what? 1. In this case, t is 1 year. Now, if I were you, I would plug that into a calculator, because it would be a very, very difficult task to try to not plug it into a calculator. But it's very important that when you plug this into the calculator, you type it exactly as it appears in the equation. 500, open parentheses, 1 plus 0.025, close parentheses, this little key right here to the power of 1. Enter. What'd you get?
512.5.
What?
512.5
In money?
dollars.
$512.50.
Thank you. $512.50. When we're dealing with money, we always write it and or round it to money. Now, how about after 5 years? What would our equation be? Y equals 500 times the quantity of 1 plus 0.025 raised to the power of 5.
Can't you just multiply by 5?
I can't because it's an exponent. So plug that into your calculator. And what did you get rounded to money correctly?
$565.70.
$565.70. Is anybody not getting this on the calculator? Okay. Now let's do 20 years. Y equals 500 times the quantity of 1 plus 0.025 raised to the 20th power.
$119, $890.
31 cents.
31
$819.31.